Hello, good evening to all. Welcome to Wallah English channel. Now, in this session, we'll be practicing more on regular languages. As you know, by this time you are aware of regular expressions, finite automata construction, and regular grammars. So, by combining all the learnings into one session, like how to identify regular languages and applying some of the closure properties on regular languages, let's see how the PYQs means previous year questions were asked in the GATE and in this subject. So we are going to see some of the questions from the PYQs. Okay, let's begin with this topics like finite automata, regular expression, regular grammars, and identification closure properties. Let's begin. First question, that is, you have a language which has even number of ones. Now L is a set of all binary strings, bit strings with even number of ones. Which one of the following expressions below represents L? So L, you require the even number of ones. So can you answer this question? Okay, one of the important model in the exam so far. Yeah, good evening, Sima. Yeah. So what do you mean by even number of ones? See, the difference is, suppose you have a language, if it is just belongs to one star instead of 0 plus 1 whole star, if it is only one star, and let's say number of A's of W, or sorry, number of ones of W is even. If this is your problem, answer is so simple, right? Answer you are going to do like 1 whole star, that's all. But this is not your problem now, even though it is even number of ones, but zeros can come any, right? So now the question is slightly changed to 0 plus 1 whole star. Condition is same, number of ones is even. That means zeros could be any, even or odd, doesn't matter. So what would be the right answer? Now, there are infinite answers again for this, but simplest answer is this is even number of ones. Now remaining positions could be any number of zeros. Zeros may come here, or may come here, or may come here. Any number of zeros may come even after, that can be covered with these zeros or these zeros. So this is a very simplest answer. But there are so many zero stars. Some of the zero stars you can ignore it. Okay, so this is a very simplest answer. Now let's look at, is there any problem with the options? If any problem with the option, we can eliminate it. Suppose if you look at this one, can you generate 1 0? Because 1 0 is having even number of ones, 0 number of ones. So can you generate at least double 1 0? Double 1 0, you have even ones, but you can't generate here. Double 1, if you come back again, ones comes. Okay, so here there are so many problems. You have single 0 you can't generate, even double 1 0 you can't generate. Such strings are so many. Even number of ones only there, but it's not able to generate. Okay, what it generates might be even number of ones, but it cannot generate all even number of ones. Now all strings we want, and that too the condition should be satisfied. Next one, it also looks like generating even number of ones, but is it doing all? Yes. Now look at this 0 star is not there, but still this 0 star is not there, and this 0 star is not there. So is it possible without these 0 stars you can generate that 0 sequences? Now look at, if we are going inside, inside, this 0 star can help to get this 0 star, because it's just coming after, right? 0 star 0 star. Suppose you want to repeat this. If you are repeating this 0 star, you can take the help from here. So this 0 star can help this 0 star. Now this 0 star you can generate with this 0 star or with this 0 star. So this is not compulsory. And when you look at this, of course these two are kept already. These are must here in this option. This 0 star can you generate without that 0 star? Now look at, if you are coming without this power 0, if you take with this 0 star, you can generate this 0 star also, because they are just coming one after other. Suppose if you go inside, this 0 star can help this 0 star, because when you are going to end, this 0 star is always there at the last. So after that 0 star is coming, this 0 star you can generate from here. So now without this 0 star and without this 0 star, you can generate the same set of strings. Yes, the option looks B is correct, but we'll look at other options. What are the problems with other options? Now see, here you are able to generate only zeros, but if I want to generate something like 11011, what is it? 11011. If see here 4 ones, even number of ones is there, but can you generate from here 1 1? If I want a 0 after this one, you need to go out. If you go out, you can't generate other 2 ones. So now if you come back, then after this one, then third one is coming without zeros if you repeat it. So now that's the issue. 11011, you can't generate in this. That's why you can't choose the option C. Option D, see, epsilon you can't generate, single 0 you can't generate, double 0 you can't generate, right? So many problems with this, because you're restricting these 2 ones are always there. Okay, so this is a issue, that single 0 you can't generate, even epsilon you can't generate. Okay, so many issues here, even though it is having even number of ones, but you can't generate. So option B is able to generate set of all strings which are having even number of ones. Okay, that's correct, option B. Let's try another one. Okay, you have 1 minute. Yeah, Lakshmi Pandey, good evening. Let P be a regular language. So P is a regular language. Q is a context free language. Of course, we don't know about context free languages, but you can answer the question without having awareness of CFL, but you can ignore about CFLs. I'll explain it in case you are not aware, such that Q subset are equal to P. So P is a regular language, Q is a CFL, and there is a relation between them. So this is given regular and this is given CFL, and so P is given something like P star Q star, and this is non-regular but it is also CFL. So P power n Q power n. One example is given. What do you mean by subset? Then which of the following is always regular? So now somebody should aware, this will be studied in the next topic, context free languages. This P intersection Q means, which is a regular intersection context free language, which will look at this example only. P power n Q power n intersection P star Q star, you will get this one only. So if you take that example, there is no guarantee, need not be CFL. Sometimes you may get a CFL, but regular, need not be regular, it's always CFL, but need not be regular, Sometimes you may get a regular, but not all the time. This example would be sufficient to eliminate option A. So option A, sometimes only regular. P intersection Q, sometimes you can, suppose P is empty language intersection CFL, you will get empty. So that is regular. But in this case, if you take example something like this, P star Q star intersection P power n Q power n, you get a P power n Q power n. Sigma star minus P, which implies P complement. P complement means regular complement. Complement of regular is always regular. So this is guaranteed always regular. Okay. Next, P minus Q. P minus Q means regular. From the regular, you are trying to delete CFL. So if you take regular is sigma star A plus B whole star minus A power n B power n. In that case, A power n B power n complement comes. So that is not regular. So need not be regular in general. In general, need not be regular. Sometimes regular, sometimes not regular. Another one, the sigma star minus Q means it's a Q complement. Complement of CFL need not be CFL only. How can be guaranteed regular? So this is also need not be regular. Of course, need not be CFL too. Okay. But its answer is about regular. So we are talking about, is it regular or not? So among them, only option B is always regular, remaining all are need not be regular, Okay. Okay, let's try another easy question, but second question was somewhat other topic support required like context-free languages. But this one, it's a purely just clinic closure property. You have studied closure properties, right? There you know what do you mean by a closure, clinic closure or clinic star of a language. So language has 3 strings. So you can say that expression something like that, AB or AA or BW. Now L star, what is L star means? AB or AA or BAA whole star. Now can you find out what are the strings are there in L star? Okay, question is which of the following strings are in L star? Okay, can you find out quickly? You can see, just underline all the possible sequences, like first AB possible when you go once, when you go second time AA, when you go third time BAA, when you go fourth time, because you have so many options, and AA. So if you go power 5, if you take power 5, if you repeat 5 times, then you can generate this string, one possible combination. Okay, second, look at first time you take AA, next time you take again AA, because there's only one option, next BAA, next AA. Yes, second one is also possible to generate. So both are there in L star. This is also belongs to L star and this is also belongs to L star. And next BAA and then AA, it's possible. Then AB, look at 3 possibilities only there when you go inside. AA, yes, it's there, and AA is there, but B you can't generate. So this whole string is not in L star, okay, because that B is alone. Now B followed by AA if you have here at the end, it's possible. Only B is left when you are repeating it right at the end. So that is not generated by L star. Next BAA, yes, then AA possible, then AB, then AA. So this is belongs to L star. Now you see that only 3 is not there, 1, 2, 4 are generated or is present in L star. Okay, so this is easy question for you, and this was asked in 2012 GATE. Okay, let's try another easy question which depends on closure properties, union and clinic star and concatenation. 3 properties we are applying here. Okay, but L1 and L2 are given, so you should fix to those languages to get the result. Okay, next, any answer for you? Got any answer? Let's try. L1 is given, right, pi, and what L2 is given? A. Okay, you can use bracket if you want to represent as a set. Which one of the following is equal to this one? Union L1 star. Can you find out? L1 is given as a 5. Okay, I am writing like an expression, so I don't need the brackets, curly brackets here. L2 star, that is A star. Union, you can take it as a plus or doesn't matter, both are same, plus or union. L1 star, that's a pi star. Okay, I am converting into expression to make it is very easily. Pi dot anything is pi, so this is pi, plus pi star is epsilon. So pi plus epsilon is epsilon. So it is a language, right? So we have only one string in the language, that is epsilon. What is the answer? A is the answer, not B. A is the answer, A. Pi star is going to have the pi power 0, anything power 0 here is epsilon. So you will get a pi star as epsilon. So most of the people might do some mistake. Pi star is also, they may consider pi. So try to avoid such mistakes. Pi star is actually epsilon. You will get a language which generates only epsilon, because here you have pi power 0, anything power 0 will represent epsilon, right? Next, okay, let's see, take a 1 minute time. The length of the shortest string not in the language over 2 symbols A and B of the following regular expression is. So what is the shortest length you need to find, which is not generated by this one? So 0 length, if it is generated, fine. All 1 length, fine. 2 length, if any 2 length is not generated, you can say that the shortest string is 2 length, so that 2 you can write. But let's find out what is the right answer for this. Any technique that you have? Yes, looks like, let's find out. So quickly you should aware that what are possibilities. You know the language, right? In general, sigma star is what? Epsilon, A, B, you know all these things, right? You should aware of it. You don't need to write all these things, but just you need to keep in mind, and you need to be in a position to apply quickly. Okay, all this you need to apply very quickly so that answer comes within a minute. Okay. So quickly you need to be applying all of them. Let's see one by one quickly. Epsilon you can generate because you can take power 0 here. Epsilon, 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 epsilon. You got it. 1a. How do you get 1a? So here a you can take here b power 0, ba power 0, a power 0. Here you got b. How do you get? Epsilon, b and epsilon, epsilon. B. Of course a you can get many other ways. I am just telling you one way. Double a, how do you get? Double a. So here you can take a square, and b power 0 you can take, and ba power 0 you can take, a power 0. You can get double a also. AB, how do you get? Here a power 1, b power 1 remaining epsilon. BA, how do you get? So you should aware of this situation, how to generate very quickly, right? Like this. Double B, how do you generate? Here b square you can write. Triple A, how do you generate? A power 3 remaining all are epsilon. AAB, how do you get AAB? A square 1b, these two are epsilon. ABA, how do you get ABA? ABA, you can get even this one. A double B and epsilon, epsilon. Okay, B double A. So you have B here, double A you can generate here. BAB, so BAB. Now this is gonna be issue. So BAB, how do you generate? If you have this expression, right? A star, B star, BA whole star, A star. So BAB, if you try to generate B here, A you have to generate here. So B, the third symbol is not possible. If you take BA here, then other B is not possible because you need only 3 length. So here this is not possible. Okay, remaining don't worry whether possible or not. You got a shortest string which is 3 length. Other 3 length is there or not doesn't matter. Here only you require to find shortest length of the shortest string, that is 0 length, 1 length, all are possible, but 3 length is not possible. So answer is 3. Okay, that too the string is BAB. Correct, 3 length. Okay, let's see another easy question, but looks very lengthy options. Which one of the following expressions represent the language which has the set of all binary strings having 2 consecutive zeros and 2 consecutive ones? Okay, just take 20 to 30 seconds or maximum 1 minute to solve this question, because answer is there, question is there in front of you, only need to match. Okay, look at each option, why that is correct or why that is wrong. There should be a reason for selecting or deselecting. You need to have 2 consecutive zeros and also you need to have 2 consecutive ones. That means 00 and 11 separately. Okay, don't look for together. 00, 11 is different. 00 and 11 is different. Okay, this question is about 00 and 11. So you need to identify all the strings which are having both 00 and 11. Okay, the first one is something like 0011 and 1100. This is different from 00 and 11 because this is not going to guarantee really no need to have 0011 like this. See, if I have a string something like this 001011, see 00 I can have here, 11 I can have here. This is a valid string, but as for the first option, option A, it's demanding 0011 coming together. So that's not required, right? Only 2 zeros should come together, 2 ones should come together, but 00 and 11 no need to come together. See, they can come even far away. So the first option A cannot generate this string. 00 is there, 11 is there, but this cannot guarantee. Option A is only looking for 0011 and 1100. So option A is not going to generate all. Option B, so looks very complicated, but it's a very easy one. If you know how to write an expression, you can easily understand. See, I'm writing in a very simple manner. If 00 is there, 11 is there. Maybe 00 may come first, 00 may come first, or 11 may come first. If 00 comes first, then your expression looks like this way. X is nothing but 0 plus 1 whole star. Okay, assume that. Or 11 comes first, then 00 will come later. Any. So this is the actual expression. What did they do is, this 2x, they took the common left side, and this 2 0 plus 1 whole star, they took common right side. So what happens when you do that? So when you take 1x common, here 1x common, what is left in between? What is left in between? This one is left here, 00 x 11 r, and this is left, 11 x 00. That's it. Now is exactly visible in the option B? That's right. Yes, Sima. Option B. This is x, and whatever you have here whole star, that is up to here, sorry, up to here. Whatever is there inside it, 00 x 00 x 11 or 11 x 00, and then finally x, that is 0 plus 1 whole star. So exactly it's there as it is here. So this is matching, but let's look at other options, why they are wrong. So if you look at option C, containing 00 or containing 11, in place of this and, if R is there, then it could have been answer C. But now because of and, the option C is eliminated, as option C only looking for 00 or 11. Only 00 is the valid string here, but here 00 is invalid string. Now in this, starting with 00, ending with 11, or starting with 11 and ending with 00. So this is also wrong option for us. Okay, that's option B correct. Okay, can you try yourself? W be any string of length n. Okay, some string, let's say 0 1 1, something like that. This is a 3 length, right? This is what? N is equal 3. This is a W be any string of 3 length, that is n length given. Let L, using this, let L be the set of all substrings of W. So set of all substrings of W, like epsilon, 0, substrings, right? 1, 0, 1, double 1. You should know what is the substring definition, part of the string, right? So L is nothing but set of all substrings. Yes, Seema, you are right. Now the question is, what is the minimum number of states in N of A that accepts L? So for this you need to find N of A. That too, minimum number of states in the N of A you need to find. Right, you have an algorithm, you can convert N of A with the same number of states. If you know the N of A for this, you can get the N of A for this. So for this you design N of A, and with the same number of states you can design a substring motion. So for this you can design something like this, 0, 1 and followed by 1. So this is the N of A for W. Now you can modify this N of A to get the motion for L, and this is the minimum motion for W, and the same number of states. How many states you got? 4 states also will be there for L. Any of 0 11 is there, so you should have these 4 states, and to accept the remaining, of course I am using epsilon transitions, but you can delete them. You have an algorithm to convert N of A without epsilon to with epsilon moves. So that also requires same number of states. You don't get more number of states there. So now to accept C, part of the string, right? You can start anywhere, you can end anywhere. So actually you are starting here, you are ending here. But as per the definition of the substring, in the sequence, you can start anywhere, you can end anywhere. Suppose in this sequence, if you want to end anywhere, after this, or after this. So everybody you can make final. Even here itself you can end. So anywhere you can end. So these are all final. Anywhere you can start in this sequence, like you can start here or here or here or here. So to do that, from here just give epsilon transition, that would be fine. That means indirectly this is the initial state, that means anybody you can start now. If you want to start here, that directly take epsilon. Indirectly everybody is the initial state. So now you look at all the strings of the L you can accept here. Epsilon accepted, 0 accepted, 1 accepted, epsilon 1 is the 1. 0 1 means 0 1 accepted, 1 1. How do you get 1? Epsilon 1 1. It's a double 1. And 0 double 1, 0 double 1. Remaining all are redundant basically. And how many states require? Just 3 plus 1 4, in general n plus 1. N plus 1 states would be sufficient to accept the L. Correct. C is right. Okay. Very famous question for the compiler oriented. The lexical analysis of a modern computer language, maybe you can take C, C++, Java, any kind of a programming language which has lexical analysis in compilation. The lexical analysis for a modern computer language such as Java example needs the power of which one of the following machine models is sufficient, necessary and sufficient sense. Okay. So which one is sufficient? Like the difference between all of them is finite automata is having less power, Turing machine has more power. So you need to choose in this order only. So which is more sufficient here? Enough, sufficiently enough. Finite state machine is able to do it, then stop here only, because no need to answer them, because that is sufficient. Okay. Now finite state automata, can it be used to represent a lexical analysis or its equivalent power you have, suppose? Why it's enough for to design lexical analysis? Because lexical analysis depends on simply tokens. All the tokens have the patterns like keywords, what else, identifier, operators. So all of them are finite finite syntax only, or you can say not syntax, it's a finite rules. So you can have the rules to frame such keywords, identifiers, constants, operators. You can make a finite automata for them. So this would be sufficient to design a lexical analysis. Okay, that is if you have a finite automata, that means you can build a lexical analysis. And of course you can use DPA to build a lexical analysis, but it's not sufficient. Sufficient finite automata is enough, right? Already finite automata can do. Why are you coming here? It's a more powerful and you are wasting resources basically. DPDA is needed a stack and many things, but finite automata do not require stack, all these things. Okay, so finite automata would be sufficient to implement lexical analysis. But if you don't have this necessary and sufficient word, then you can choose all the four. All the four can do indirectly. Okay, in the future, if they delete simply, what do they say? Which one of the following machine models? If that they stop, then you choose all the four. But this time, necessary and sufficient, you can go for finite automata. Okay, let's see. What is the complement of the language accepted by the NFA shown below? Now you have an NFA, you need to identify the language accepted by this NFA. Okay, don't do complement, nothing but interchanging final non-final, that you do for deterministic machine, you don't do for non-deterministic machine. Carefully look at it, it is not a deterministic machine. If it is a deterministic finite automata, you can do interchanging final non-final, but now don't do that. Okay, doing interchanging final non-final, that's only valid for DFA. Never do for NFA, because NFA could not give complement of a language. Now look at this. What is the language? You need to identify what is the language. What is the language for this? A is accepted, and then if you look at any other string, A followed by A, it's double A. Triple A also you can accept. A, epsilon, epsilon, again A, again A. So except epsilon, everything else is accepted. That's A plus all the strings are accepted. A plus all the strings are accepted here, except epsilon, all strings over A accepted. Now somebody is asking L complement, that's it. L complement over the A, that's a sigma star minus L. The sigma star is here A star and L is A plus, you have only epsilon. So that is the complement of L, right? It's simply epsilon. In case if you do something wrong, like if you make these two are finals, then your answer is going to be A star. So that answer also there. Never try to do interchanging final non-final for NFA. You may not get a complement of, here they ask complement of a language, they didn't ask you to interchange final non-final, right? You're talking about non-deterministic machine. So you should be very careful what is the question about. They asked two types of questions so far. They asked to interchange final non-final, then do that. They ask complement of a language, then don't interchange here because it is non-deterministic finite automata. Okay. Next, consider the DFA given below, and now which of the following are false? Can you identify the false? Which of the following are false? Can you try it yourself? I'll just give the names A, B and then C. First, is it finite automata? Yes. So what is the language? Regular. And if it is a regular, complement of a regular, definitely regular, right? So complement of a language, you will get a context free, because regular you can call it as a context free. Regular is context free, but context free need not be regular. So this language is regular. Language represented by this machine is regular. Complement of regular is always regular. So complement of regular, you can say context free, that works. So this is a true. The first statement is true. Now the second one, the language what is written here, is that correct? Just you need to match, is it appearing like this? So this is the final, right? Just look at one path is 0 followed by 0 or 1 whole star. Is that there? You can see there. That's A represent all. A is the machine name, right? Okay. Language is, what did they mention here? 1 1 star 0 or 0 followed by, you know, everything is 0 plus 1 whole star. You don't need to write the 0 star 1 star, because you know 0 plus 1 whole star followed by 0 star 1 star, it's same as 0 plus 1 whole star. You don't get beyond this, right? Every string over 0 1 you can get from there. You can always assume epsilon 0 power 0 1 power 0, you can get everything from here. So now you got this form. Is this present here? You see, if you come to this path, 0 followed by anything, right? So 0 followed by anything is there. And if you come by this path, 1 1 star 0 followed by anything, 1 1 star 0 followed by anything. So when you look at this expression, exactly what is given and what is written, they are actually synchronizing, they are same. Okay. So option 2 is, the statement 2 is also true. You don't need to do any extra work, just understand. For the language accepted by A is minimal DFA. Now first, is it DFA? 0 1 and 0 1 0 1. Yes, it is a DFA. Is it minimal DFA? Just what you do is apply some minimization algorithm, like, you know, all the non-finals you keep one side, all finals you keep other side. Now just you need to compare A, B, can they combine? Because AC, BC never be combined. A, B, can they combine? Let's see, A and B on 0, actually they are doing C, C is here, okay, they are coming to the same set. And A on 1, B on 1, they are actually coming here. That means both are doing same. You can combine A and B, you can get something like this machine like this, A, B. And what you can do now, when you combine it, on 1 you can put a self loop, on 0 you can go to C. That's it. This is your final machine. So this can be written as, if you look at this, right, 0, when you take a common, here itself you will know that it's just 1 star 0 followed by containing 0 machine. So containing 0, you just require 2 states, but they're designed with 3 states, and this is the false, because they are saying it is a minimal. Actually it is not a minimal. You can design with the 2 states for representing same language. Okay, last one. A accepting all strings over 0 1 of length of at least 2. See, single 0 is accepted, right? So they are saying at least 2, but actually it is at least 1, that 2 containing 0. Okay, this is also false statement. Actual problem is containing 0 as a substring. So you need to identify false statement. 3 and 4 are false statement. So that is option D. Option D is the 4. The 3 and 4 are false statements here. Okay. Let's look at another easy question. Yes, good. Now L1 is A power n, L2 is B power n. L1 dot L2, because regular dot regular is regular, and you can easily represent. See, L1 is given A power n, L2 is given B power n. Now of course you may represent with the set notation, that's okay. And now when anybody says L1 dot L2, always remember you should not use the same power. You should use something like a power I, b power j, something like that. If you use powers, right, what happens? You are relating, if 100 a's are there, then 100 b's, not like that. Here any number of a's followed by any number of b's should come. Now this should be your answer, a power I, b power j. Now this is your expression, which is same as a star b star. In fact, a power n you should assume like a star, and b power n you should assume like b star. But when you concatenate, do not use the same power n. If you do, anybody writing a power n, b power n, actually you are not doing the concatenation of two regulars, you are doing something else. This is not a regular at all, okay. And now first one, concatenation of two regulars is always regular, this is a correct. And option B, sorry, statement 2, L1 L2 is not a power n, b power n, it is a star b star, okay. Should not write. So here only one, which one of the following is correct? Only one, that's true, correct, A. Yes Seema, you are right. Okay. Can you find out quickly what is the right answer for this? Consider the two DFAs, the number of states in a minimum DFA that accept the language. Okay, take time to answer this question, because the numerical answer type, so only one way that you can answer by doing it properly. Do not guess at all. If you guess, maybe you will not get negative marks, but if your answer is wrong, you will not get the marks. Now what is L of m here? What is L of m here? Ends with a. Oh, what is ends with a? You can simply write as a plus b whole star followed by a. This ends with a. What is L of n? Look at who is final here. Oh, this is the final. When will you go to final? When the string ends with b. You can see incomings to this final. Okay, initial to final. When the string ends with b, very famous machine, right? It ends with b. Now what did they ask? Intersection. Is there any string common? See, this string ends with a, this string ends with b. Even single string is also not common. So the language is going to be result. If anybody asks intersection, intersection is just pi, you get nothing. If I do the union, you will get except epsilon everything, a plus b whole plus you will get. So this is about intersection. Common strings of this two, you will get nothing. And the question is about now, it's not about the language, it's about the number of states in minimum DFA. How many states in DFA? If you design a DFA to accept the empty language, you will be having the machine like this, right? This machine is the minimum machine, minimum DFA. So the answer is going to be 1. Okay. Sometimes question may be asked, how many strings are there in the language after doing the intersection? Number of strings is 0, but number of states to accept that language is 1. Number of states. Yes, 1 is the right answer. Correct. Okay. Number of states and minimum DFA corresponding to the regular expression is given. That is ends with 1 0. What is the machine? The language is ends with 1 0. You need to design a machine to accept all the strings which are ending with 1 0. Okay, how do you design? In a shortcut, you may take like this. The minimum string is 1 0, which is 2 length, so 3 states. If anybody practice that construction of DFA, it can be answered in just 5 to 10 seconds after reading the question. Okay. Now you got that minimum string is 1 0, so your target goes to the minimum string always. Okay, this is the minimum string, and only minimum string accepting. Now this machine need to convert into DFA. This is not a DFA, right? So from here you need to cover 0, here you need to cover 1, here you need to cover 0 1. So those are the transitions are missing. Now here, before ending with 1 0, any number of zeros are coming, you can wait. Okay, after 1, any number of ones are coming, you can wait here itself, because 1 0 1 1 0 both are ending with 1 0, so there is no problem to the string. And after ending with 1 0, if 0 comes, again you need to look for 1 0, that's why you will go to the initial state. but after 1 0, if 1 comes, you can go to the previous state. Again when 0 comes, you can come back to the final. So 1 0, whenever the string ends with 1 0, you can come to the final. So this is the final machine, which requires just 3 states. And designing DFA might take time, but answering the number of states, it's so easy, and you can follow the shortcut too. So number of states will be 3. Okay. Let L be the language represented by the regular expression, that is containing 0011, right? What is the minimum number of states in DFA that recognizes complement of L? Okay. So now the L is given to you, expression of course, the containing 0011. Do you know how many states required in DFA for this? Minimum length is 4, so 5 states in DFA. In minimum DFA, and you don't need to design also, it takes much time to design. And now the question is about minimum number of states in DFA that recognize complement of L. When L requires 5 states and the same 5 states but interchange finals and non-finals, you get 5 states in minimum DFA, but that accepts L complement now. So this is for L complement. This is for L. Now you can design same DFA but interchange final non-final, you get the 5 states. But you should know first, why do you require 5 states for containing 0011 and not containing 0011 will also have the 5 states. So now the answer goes to B. Option B is the correct. Okay, it will not take much time, but designing will take time. If you are aware of the machine, don't design. If you are not aware, please try to design. The number of states in the minimum DFA that accepts the language defined by the expression. What is this language? Anybody aware of this? It is simply 0 plus 1 whole star 0 or 1. It's at least one length, right? At least one length. This is exactly one length. This is a greater than or equal to 0. This is a greater than or equal to 0. Simply you can say greater than or equal 1. You can write it as 0 plus 1 whole plus. You can simplify. For this, what is the minimum DFA? Except epsilon, everything else is accepted, right? 0 or 1, you can accept here. Okay, this is your DFA. This is your DFA. And requires how many states now? It requires just 2 states. Okay, it's easy, you see, hardly it takes 1 or 2 minutes if you are aware of the concept. Okay. Consider the following 2 statements. Now first statement, if all the states of NFA are final states, accepting statements, final states, then the language accepted by NFA is sigma star. Oh, instead of NFA, if you have a DFA word, this statement could have been correct. In NFA, if all the states are final, the language need not be sigma star. Here, instead of is, if they give need not be sigma star, this statement could have been correct. Okay, this statement is correct for DFA. In a DFA, if all the states are final, then it will accept sigma star, but in NFA it is not. So this statement is false. HS statement should be like need not be sigma star. For the NFA, need not be sigma star. Okay. Second statement, there exists a regular language A such that for all languages B, A intersection B is regular. So there is some regular intersection. For every language, you take any language here, the result should be regular. So there is some regular here. Can you find out, do you really have some regular so that intersection with every language, the result is regular? Do you have any such? You can see that some regular, if I take pi intersection, anything you get, that is any language you take, the answer is always regular. Yes or no? That means you are able to find some regular here. Then the whole statement is correct, and absolutely we are able to find there exists a such that for every B, A intersection B is regular. So this is the true statement. When will become false? Instead of saying there exists A, if they say that every regular language A, if you say that, then this statement could have been wrong. Okay. So only 2 is the correct. Which one of the following is correct? Only 2 is true. Only second statement is true. Okay. Now next one, consider the language L given by the expression. This one is, last symbol is anything. So this is second last. Second symbol from end is B. Second symbol from end is B. So last symbol could be anything, but second symbol from end is B. Simply you can design with a 2 square, 2 power, what is it? Let's say kth symbol here. Then formula will be 2 power k, which will be 2 power 2, 4 states needed. That's it. If you really want to design a DFA, then this will act like ends with BA or ends with BB. So you need to design like ends with BA or ends with BB. And this is the language. The machine should be like this. B is common, but it may end with BA or it may end with BB. And after designing this machine, you try to make a DFA. For this you need to work out how to make the DFA, because here A is missing, you will get a self loop, and this state covers A and B, this state missing both A and B. If you get A, what will happen? If you get a B, if you get A, again you need to start, but if you get a B, BA, B, so that B might be this B, so you should come here, because this B followed by A is ends with BA, and after double B, if A comes, then that's going to be this one, because that's ending with BA. After B, if any B's comes, then it ends with double B. Of course this could take time, but if you have a practice, very easily you can design it, but don't worry about it. Already you got a formula and you got an answer. So answer is going to be 4 states. What is it? Answer is going to be 4 states. This is for extra knowledge, how do you design, but without this you already have a formula 2 power k. If it is third symbol from right end is B, then 2 power 3, 8 states will take. Yes, that is for same, that is for NFA. If it is given for, it's a deterministic, right? If it is given non-deterministic, then answer will be n plus 1, that too. N plus 2 is wrong, n plus right. Left side it is n plus 2, correct, you are right. For from second symbol from beginning is B, then it is n plus 2 for DFA, correct. You have a formula, right? You can keep it, that's correct, Okay. The minimum possible number of states in a DFA that accepts a regular language. So what is given? This is 2 length and this is minimum 3 length, greater than or equal to 3 length. It's mentioned here, right? And exactly 2 length is the minimum 3 length. So 2 length means what? A plus B whole square, and A is fixed, and then minimum 3 length. How do you write minimum 3 length? A plus B power 3 followed by A plus B whole star. Now this, for this language you need to build a machine. How do you do that? First 2 length is any, so A or B, then followed by A, then followed by 3 length, 1, 2, 3, and then after that any sequence is fine. And here one thing is missing. If B comes at the third position, then it should be going to dead state, and you want a DFA, right? If it is NFA, you don't need to cover this because you need a DFA here. So total how many states? 4, 8, total 8 states needed, Just count that, 8 states needed. Yeah, you are correct, it's 8 states. Okay, some assignment questions after watching this video. Please try to answer these questions one by one. So this question 1, you have the 4 options, you need to choose accordingly. And second question you have here, you need to find all the states that you can reach after reading ABA from state Q2. Okay, you have NFA with epsilon moves here. Again, 2 statements, you need to find the correct statement from them. Yes, which one of the following DFA, and problem is there, answer is there, just you need to look at which one is the correct one. Okay, and now you have some statement like some regular languages there for the DFA with k states, and which one of the following must necessarily be accepted, minimum DFA with k states, which one going to be, right? Options are given, choose one of them which is matching. Okay, yeah, thank you so much for watching this video. Yes, you can find out video, right? You can ask in doubt session, definitely you will have a link, it will be uploaded every day, right? So please find the PDF, go to the main, you can search for this series, you will definitely find. Yeah, thank you so much, bye bye.